Hello, future engineers, subscribers, viewers, and students. This is the solution to problems 3 and 4 given as problems in the final exam in structural theory LEC from the university where I teach structural theory. So, determine the maximum bending moment in the beam shown. There are two possibilities. It may be moment at B, which is negative, moment at C, which is also negative, or moment somewhere in between B and C where the moment is positive. So before that, let's solve for the intensity of the loading, which is denoted by WB as shown in the figure. So this is WB, and let's divide the trapezoid into two triangles by this blue dashed line so that the intensity there is WB minus 30. And in this part, this portion here is WC minus 30. So by similar triangles, WB minus 30 as to 3 meters equals 45 minus 30. So this is 45 kilonewton per meter minus 30, or simply 15 as to 15, since 45 minus 30 over 15 is 1 times 3, so 3 plus 30, 33. WB therefore is 33 kilonewton per meter, and we equate it further to W sub C minus 30 as to 13, so W sub C is 43 kilonewtons per meter. Dividing the trapezoidal loading into this by black dashes, this one, divide the triangle. So the moment of the lower triangular loading is 1/2 of 3 times 30. This moment arm is 2/3 of 3, so 2 meters. That's one. Then plus 1/2 of 3 times 30 times 33 rather. This one. Then moment arm is 1/3 of 3, so 1 meter. So one possible maximum moment, which is negative, which is occurring at B, is negative 139.5 kilonewton meter. The other possible negative moment occurs at C. So dividing the trapezoidal here, trapezoid into this manner, for the lower triangle, 1/2 of 2 times 30, the moment arm is 1/3 of 2. So that's why it's 2/3. Sorry, 1/2 of 2 times 43, the entire intensity here is 43. Then 1/3 of 2 is 2/3. For the upper triangle, 1/2 of 2 times 45, the entire value here is 45. 2/3 of 2 is 4/3. So the other negative moment, which is at C, is negative 88.667 kilonewton meter. So far the maximum is negative 139.5. Then at between B and C, where the maximum moment is expected positive, so call this intensity W at distance x from the left, so that would be W minus 30. So W minus 30 as to x equals 45 minus 30 as to 15. Therefore, W in general is x plus 30. Shear in BC can be set up by first solving R sub B. Summation moment about C equals 0. Let's divide the load by this purple division line. So for the lower triangle, the moment RB times 10 equals moment of the lower triangle, 1/2 of 15 times 30. Then supposedly the distance of the centroid of this lower triangle from D is 2/3 of 15 is 10. Then 10 minus 2, because we sum up moment about C, is 8. So the moment arm is 8. Plus the moment of the upper triangle, 1/2 of 15 times 45. The distance of the centroid from here is equal to 1/3 of 15, so 5, but minus 2. 5 is from the rightmost end, 1/3 of 15, so 5. But from C, 5 minus 2, so 3. The value of RB is 281.25 kilonewtons. Then shear in BC is RB, which is 281.25 minus the area of the trapezoid, 1/2 of quantity 30 plus W, and W is x plus 30 times distance between 30 and W, x. Then we set it to 0 because we want the point where shear BC is 0. So 281, shear BC is 281.25 minus 30x minus 0.5 of x squared. Then equate it to 0 and solve for x. The only possible value of x which lies within between 3 and 13, it should not exceed that range, is 8.2426 meters. The other values are absorbed. So from there, W is x plus 30, so 8.2426 plus 30, 38.2426 kilonewton per meter. So the maximum moment here is simply we sum up moments about that section immediately. So it is RB to 81.25 times quantity x minus 3, so 8.2426 minus 3, that distance there, then minus the moment. We divide the trapezoidal loading up to W by this green dividing line. So the moment of the lower triangle, 1/2 of x times 30, so minus 1/2 of x, 8.2426 times 30, and the distance is 2/3 of x. So moment arm, 2/3 of 8.2426. Then minus for the upper triangle, 1/2 of x times W, and W is 38.2426. Then 1/3 of x. The moment arm is 1/3 of x, 1/3 of 8.2426. So that's why the maximum moment is 362.04 kilonewton meter. So Max, our answer is 362.04 kilonewton meters because it is greater than 139.5. Let's proceed to problem 4. Determine the horizontal reaction at support C for the semicircular 3-hinge arc frame shown below. So for the horizontal reaction at C, I denoted it with Cx, and this is Cy. We have Ax and Ay. So considering the whole system, summation moment about A equals 0. For simplicity, I denoted the radius of the semicircular arc as 1 meter. Although you can mark it as R, but R is present in all terms, so you can simply cancel it. So it's better to call it 1 meter or assign it as 1 meter. By principle of transmissibility of a force, this 40 kilonewton can be moved along its line of action at the center here and resolve it into two components. By the way, the value of theta 2 is 30 degrees. 3 theta 2 equals 90 degrees. Some of you were not able to analyze this, my students. So that's why your problem is really mathematics. This is a very simple problem in statics. I gave this in structural theory so that you can answer it, but I was surprised. Only few of you were able to solve this. So that means your problem really is not structural theory. You cannot survive in structural theory if you do not enhance your skills in mathematics, I tell you. You keep on repeating this course if you do not enhance your skills in mathematics. Do not say it's your 4th time, 5th time. Of course, it will be n time, 100 times, because you're not following my suggestion that you have to develop your skills in mathematics first. Is there no time? There is very big time. Would you like to repeat the course? Then do not follow my suggestions. This is theta 1, theta 1. So 2 theta 1 equals 90, so 45 degrees. Therefore, this vertical distance is hypotenuse 1 sine of 45. 1 sine 45. That's also 45 degrees. And by principle of transmissibility of a force, the horizontal component is 40. This angle is 60 degrees, so 40 cosine 60, 20 kilonewtons. The other one is 40 sine 60 degrees. So considering the whole system, summation moment A equals 0 to solve for Cy. Then later we consider BC, summation moment B, we can solve for Cx. So summation moments about A equals 0, counterclockwise positive Cy times 1 plus 1 or diameter 2, then equals first the moment of 50, 50 times 1 sine 45 plus the moment of 40 sine 60 because 40 cosine 60 or 20 kilonewtons passes through A. It has no moment. So plus 40 sine 60 times radius 1, then plus 60. The moment arm is 1 meter plus 1 cosine 30. So Cy is 90.975 kilonewtons. Then, considering BC, summation moment B equals 0, then Cx clockwise times 1 plus 60 times 1 cosine 30, then plus 20, this component of 40 kilonewton, 20 times 1 meter, then equals Cy times 1 meter. So Cx is 19.017 kilonewtons. Is that difficult? That's very easy.